So now then, that further gives us abilities to accommodate that change that we want to accommodate for our customers. You know what I'm saying? It's just another factor. Test-driven development forces us down a path to write code that is more loosely coupled, more context insensitive, so that it is more flexible, but it also gives us a security blanket, a way to validate that our changes aren't breaking anything else. So that's really unit testing. One other thing I'd like to mention is behavior-driven testing. And behavior-driven testing, or behavior-driven development, excuse me, is another, it's like the next, if you took unit testing, you drove it to the next level, you get test-driven development, you drive it to the next level, you're going to have behavior-driven development. And basically what that says is you're going to talk in terms of the user, or maybe not even the user. Well, it would always be the user, but sometimes that's the user of your software, but sometimes it's going to be somebody that's consuming the module of code that you're writing, would be your user perspective. And it would say stuff like, basically the way behavior-driven development works is it's going to say, given, when, or given, when, then. Basically, you set up your context, your preconditions, an action happens, and then you're going to validate that the state of the system is what you would expect after that action happens. So it's really a good way of thinking about problems, and it helps you to really deal with complexity, I believe, because it forces you to think about the problems in a way that allows you to easily decompose these problems. Next is continuous integration, and really this is taking unit testing even farther, because in unit testing you're testing each individual units in isolation, apart from the rest of the system. But that's good, but you also want to test those components all together. So what continuous integration allows for is that if you have a build server and you have multiple developers contributing to a code base, then this build server would continually check out the code, make sure that it builds, again, so that you can catch those errors early when they're the cheapest to fix. You then catch those errors early. Also, it builds errors, but it can also run your entire suite of tests as far as your integration testing. You may set up tests in here, automated tests, that will drive your system all the way through from beginning to end, so that you know all of your components that you've now put together work together the way that you would expect. Again, just another form of validation. But it's a way to automate this validation so that you don't have to have 100 people sitting over there constantly banging on code. Oh, I'd like to step back one here too on the unit testing and the behavior-driven testing. If I write something, so let's say for example, when application starts up, should initialize dependency resolver, okay? That would be a setup for a test. I can write this in English like, the name of the test class would be when application starts up, then I have a test case that would be should initialize dependency resolver. Now I can have some assert statements inside of this test that say, was the dependency resolver initialized when I called application start? What that does too is it's also communicating to somebody, it's communicating to myself when I come back in 6 months and look at this thing, I can read what my expectations were. I can also, it will also communicate to developers that come along behind me what my expectations were when I wrote that piece of code. So it's documenting the code there. The other thing that is really good about tests, that I think is a weakness of other forms of documentation is that if you have tests that are passing when you run them, execute them, you know that is what your code is doing. They cannot be out of sync and still pass. So now then the tests that document your code are executable, so they're always in sync. So your documentation is never going to lead you astray. Does that make sense? I think that's another critical factor, especially when you get to the level of behavior-driven development, because really you're setting expectations for your code, and then you're validating those expectations. And it's documenting at the same time. I mean, there's just so many things going on there. Again, another tool that we talk about, or we do, is code smells and refactoring. I kind of group these two together because code smells are really documented scenarios in code that happen that cause your code to be less flexible, more brittle, more viscous, harder to change. They're just documented things that you can look for. Similar, like one of the worst code smells is duplication. If I duplicate logic in more than one place in my code or in my application, and 6 months later a bug comes up and I got to go in there and I got to fix it, well, I go change it in one place thinking, okay, I got it fixed. Well, really it exists in two. But what ends up happening? Instead of that bug always showing up, it now becomes an intermittent bug. Because sometimes the code's executing over here, which I changed, and sometimes it's executing over here, which I didn't change. So that's one code smell. There's many code smells. And there's a very good book by Martin Fowler on refactoring that defines a lot of code smells, and also refactorings. Basically what a refactoring is it's a change to your code, the structure of your code, without changing the observable behavior of your code. It is a very small change that you make to your code so that overall your unit tests that are testing that code won't need to change. They'll still pass once a refactoring is complete. But it allows you to improve the quality or the structure of your code. One other thing that I would like to, that I don't think I have on here, that I think is very important is when we write our code should always show our intent. Again, another form of documentation or a way of communicating to the future, whether it be ourselves or someone else. We always want to show intent. So when I say show intent, we should name our functions according to what they do. And we should name our variables according to what the values they hold, or our classes. If we name something X, Y, Z, what does that mean? It doesn't really show me any intent, what that was supposed to hold. If it holds employee count, then I know, hey, in here is employee count. Well, one of the things you want to do when you consider refactoring your code is you want to evaluate how well does your current code, the way it's written, communicate the intent of that code. To write code that's obscure is really, again, contributing to the complexity problem that we need to manage. That's something we have to manage. So, again, your refactorings would allow you to go back. Oh, and again, I said I would be bouncing back and forth. Unit testing allows you to do these refactorings safely, because if you've written a test on a particular unit of code and you know what that code is supposed to do, you've got a test in place, you go in there and you refactor it for it to show intent or to eliminate duplication or whatever. Once you're done with that refactoring, you can then rerun your automated test to make sure that you didn't break anything in the process. Again, just another safety